Hi everyone, respected sir. I'm Sunil Sapkota. Today I will be presenting the presentation of my project. Basically, it's a question answering project using a squad version 2 dataset. Uh, the system mainly have three parts. They are like global vectors, embedding global vector embeddings, bidirectional GRU encoders, and bidirectional attentions. So let's get started. So let's have a project overview. So what does the project do? It reads a passage and a question, then find an answer directly from the text. The tricky part is that Spot 2.0 includes questions that have no answer at all. To handle that, I added a special no answer token to a model that can say, I don't know, in a clear way. The model has 8.66 billion parameters, but only 614K are trained. The rest are frozen, just to make sure to reduce the overfitting thing. And the summary of the project is highlighted here. It's like exact match is 37%, and the F1 is like 42%, and no answer accuracy is 58%. For vector For word vectors, I used pre-trained global vector embeddings. Each word becomes 100-dimension vectors. So I just used 100 dimension. The project requirement was like use 100 or 300. I kept them frozen during the training, which cuts trainable parameters from 8.66 million to like 614K. That reduced the overfitting, and the downsizing is about 17.6% of the word aren't in global vectors and fall back to UNK. The same embeddings matrix is shared for both the context and the questions. Now here is the dataset and task understanding. So looking into the data, we can clearly see that context passages have 50 to 250 tokens long. So I set the max is to 20. The questions are much shorter, around 10 to 15 tokens. About 67% of training examples is unanswerable and 33 are unanswerable. This imbalance means the model sees more answerable examples, which is the part of why over answers unanswerable questions. The pipeline has 4 steps, as you can see in the picture. So first one is obviously the input. Then they will be converted into the tokens. The token goes through global vector to get the embeddings. Then a shared bidirectional GRU reads both the context and the questions. The bidirectional means it reads forward and backwards, giving 192 dimensional outputs, which go to those will go to like bidirectional DFA attention, which compares context and the questions to find the relevant part. Finally, two outputs head predict the start and the end of the answer span. Position 0 is always the no answer option. Yeah. So that was the architecture of our project. So let's see the training configuration and hyperparameters. So we have used like global vector dimensions to 100D. So I already told about this 100 dimension. We can use 100 or 300 dimension in our project. So I have used 100 dimension. Max content length is like 220 tokens. You just cover almost everyone, not all. You can also add this number of max content length and add a lot of other tokens as well. Max question length is 32. Bidirectional GRU hidden size is like 96 per direction. Batch size is 64. Drop rate is 0.2. Optimizer 0.002. Trainable embeddings is false or frozen. So I basically explained earlier as well, like out of total like 866 million, I just used 614k. Early stopping 2. So early stopping 2 means like if we have VAR loss value above, like the loss is increasing for continuously 2 times, then we'll stop the epochs and we'll get the best loss value data in our model, is our model. I'll explain what I'm saying it in the later slide as well about this early stopping. So here we can see the early stopping thing. Yeah. So if you see the VAR loss, so it was like 3.8% loss for the first time, and it goes all the way to like 3.7 or something like 3.6, something like that. And 3.7, it increases and again increases. So consequently, like we have said, like for the 2 times, if it get worse, then we'll say like we'll stop the early phase, even though that the epoch was 10, so it should iterate up to the 10 times, but in the fourth time it stops because it just found out that it is overfitting. So to reduce these overfittings, we just stop at here. So result, I have already explained this in the project overview as well. So we have like exact match of 37%. We have effort score of 42, and no answer accuracy is like 58%. I'll explain this 58% in like next slide as well. So here is our next slide. It is a confusion matrix. Yeah. So the model predicted true, I mean answerable, but and the actually dataset also have the answers or answerable. So those data are the highest data. So they are like 4,100, 4,019. Those who says like the model says we cannot predict the answer and actually there is no answer in the dataset as well, those data are like 2847. So the wrong data is like model says we can predict, but actually there was no data, no answers. So this data is like 1098, and the model says no answer, we cannot predict, but there was a answerable context. So the data is like 1798. So if you sum these two and these two and take out the percent, like these two are obviously the right one and these two are the wrong one. So converting the percent, it will create like 58% of on 58.37% of accuracy. We can obviously decrease this value and this value and increase the like accuracy of no answer by tuning the hyperparameters. And here is the simple output prediction and the demo. In the code, I have explained like we have taken 3 examples of like 3 rows. So first one is from row 0, and second one is from row 4, means like 5th row, and last one is 100th row. So you can see like there is answers and their confidence. The first answer is like France, and it's like 91% accuracy. So in conclusion, to summarize everything, the pipeline works end to end and the scores matches that expected for this model. The main weakness is like 301,100 false positive on the unanswerable questions. So that was a pretty huge number of false positive that we can see it in the sorry, yeah, that we can see here. So 2098, it's almost like 3100. It's a huge number, and yep, we can fix it using updating some uh, hyperparameters. So future improvements could be just unfreezing the embeddings, increasing that epos, uh, tweaking some other hyperparameters, and that's it. Maybe Keras masking issues, attention layers, upgrading the brat, uh, yep, adding dedicated no answer head, right? So that's everything. Thank you so much for the listening. Thank you for your time. Thank you.